This is my video demonstration for CSC120, and this is for section 4B. This is where I'm going to be demonstrating my understanding of algebraic expressions and being able to convert those expressions to truth tables, and then to be able to convert algebraic expressions and truth tables to logic circuits interchangeably. So first I wrote out this algebraic expression here, and what this is saying is that on your truth table you're going to be looking for what outputs to the true statement, or 1. So you're looking for where this equals 1 and this equals 1. And by the complement is that you're going to have the a prime, or a synonym for that would also be the using an inverter, or just basically an opposite term for that. And a prime, when a prime equals 0, it equals 1. So when a prime equals 0, it actually, with the prime, it's going to be equal to 1. So converting this algebraic expression to the truth table, you'll be able to see that in a better visual representation. So looking over here, we'll just go for the truth table per usual. So you'll have 0, 0, 0, 0, 0, 1. You get the idea. Okay, and then when they're all being ANDed together, it's going to be equal to 0. This is going to output 0. However, when they're all prime, you'll have 1. So this is where you're going to be able to visualize when your algebraic, or your boolean algebra, is equal to 1. So we'll just move forward, keep it going. Okay. So with the expression giving out when it's equal to positive, that is called a. So my midterms from this truth table for our algebraic Boolean expression states that the product of these literals right here is, they're not complemented, but once they are all true, A, B, and C, you are outputted with the true. So that is going to be your midterm 1. So you can abbreviate that like so. And when you have the product of the literals here, you're going to have to take the complement of A and B, and thus when you execute A and B is 1 and C is 0, that is when you will have the midterm also written like so. And finally, you're going to have the complement of all the input variables for this product of literals, where when they are all equal to 0, you will take the complement and it is equal to true. Alright, so first I'm going to draw out this, which is just a big 3 input AND. Then you got your OR, and again, it's going to do it with the 3 input AND. Got an OR, and again, 3 input AND. So for the complements, I'm just going to use an inverter, which is a NOT, which is this symbol. Yeah. Just a line with a triangle and then a little dot or a circle in the front, and that inverts it. Alright, this is my very rough sketch. However you get the logic, I just use the 3 input ANDs because I think it'd be easier than using a multiple 2 ANDs with another AND. And then the ORs and the inverter NOTs. NOT is just the complement, so it equals 0. Again, NOT will output 1, and vice versa. When it's 1, it will output 0. And to show you my very roughly sketched diagram, I label them M0, M1, and M2, which, as we know, this is M0, this is M2, or sorry, M1, and M2. So 0, 1, 2. And then they are all, so these two are ORed with this last 3 input AND.